In this lesson, we're going to study intercepts. So first, we're going to identify intercepts. Intercepts is the point that crosses the axis, either x or y. So let's look at this graph. This graph here, I have two intercepts. One crossed at the y-axis. So this point here we call the y-intercept. So let's write it down. This is y intercept. Since this point here crossed at the x-axis, so we call this point right here as the x-intercept. So just type it easier. So this point here called the x-intercept, and this point here called the y-intercept. Now let's identify. So this point here is your x coordinate is 0, so got 0, comma 4. That is your y-intercept, and this point here will be minus 2 is your x, and the y coordinate is 0. So these are the two intercepts of this graph. Let's try one more. In this graph here, we have three intercepts. This one, and this one. You have two x-intercept and one y-intercept. So this one is your y-intercept right here, and it's located at 0, comma 3, because the x value here is 0 and the y is 3. And for this point here, our x-intercept will be minus 1, comma 0. And right here we have minus 3, comma 0. So at this point here, when your x value is minus 3, y value is 0. And right here the x value is minus 1 and the y value is 0. So you have a y-intercept right here. Right here you have y-intercept. Okay, and right here we have two x-intercepts. So it's x, it's the y-intercept. Right here you have x-intercept and x-intercept. Okay. Now notice that every time we have a y-intercept, the x value is 0, and when we have the x-intercept right here, the y value is 0. So it's a good thing to remember that. So next we're going to find the x-intercept to the graph of the linear equation. Okay. Now giving the equation on a line to find the x or y-intercept actually very easy. Now since we noticed that to find the x-intercept, the y is 0, so why not let y equal to 0 and solve for x? Then we have the x-intercept. Now to find a y-intercept, since the y-intercept is your x coordinate is 0, so we'll let x equal to 0 and solve for y. That's how we solve for the y-intercept. Okay, so let's try the example. Let's see how it works. I want to graph this equation by using x and a y-intercept. So let's try to find x-intercept first. Now remember, the x-intercept is the point when the y-coordinate is 0. So we let y, or we set y equal to 0, either or. We let y equal to 0 and we will solve for x. So I replace this equal to 0. So I have 4 equal to x minus 3 times 0. Right, now 0 times number is 0, so we have 4 equal to x. So the x-intercept will be the point. Y is 0, x is 4. So right here is our x-intercept. To find the y-intercept, now y-intercept is when you have the x coordinate is 0. So to find the y-intercept, we let x equal to 0 and we solve for y. So we let x equal to 0 and solve for y. So you got 4 equal to 0 minus 3y. To solve for y, and let's rewrite this again. I think I need to erase something that I'm not supposed to erase. So I got 0 minus 3y is minus 3y. And right here I have 4. To solve for y, I divide by minus 3 only. Okay. We solve for y, so you don't want to divide by y. So this here cancel out. So we have only one y left. So I have y equal to minus 4 over 3. So our y-intercept will be 0 minus 4 over 3. Okay. So now we're going to graph. So now we're going to graph. I just change the paper into the graph paper so we can graph nicely. So right here is the x-axis and right here is the y. So to graph the x-intercept, when x equal to 4, y 0, so right here is 1, 2, 3, 4. So right here is the x-intercept. Now y-intercept is when x equals 0, y is a minus 4 over 3. Minus 4 over 3, you can convert it into a mixed number by divide 3 inside 4. You have 1. So you got 1 and third. So now if you put minus there, you have minus 1 third. 1 and third, ooh. Here's 1, here's 2, 1 and third somewhere around here. Approximately. I can do the point too small, it won't work. Okay, so 1 third is around minus 1 third around here. Alright, so now we connect the 2 points together. We have the x-intercept, we have y-intercept here. So now we can connect the 2 points together. So I connect the 2 points together, I have this line here. Okay, so that is our graph. Let's draw another example. So we want to graph this equation by using the x and y intercept. I try red. So once again, let's try to find the x intercept. To find the x-intercept, we let y equal to 0 and solve for x. So I have 2x equal to y, but y is 0. Now to solve for x, so divide by 2. So x equal to 0. 0 divided by a number is 0. So our x-intercept will be 0, 0. To find a y-intercept, we let x equal to 0. So you have 2 times 0 equal to y. But 2 times 0 is 0 equal to y. So the y-intercept is 0 and 0. Well, so now 0 and 0 is actually the point at the origin. So the origin is both x and y intercept. So we have actually only have one point. But to graph the line, we need at least 2 points. So what I'm going to do is I'm going to try to find a point beside the x and the y intercept. Pick another point. Let's try to pick x using the table like this one. Let's use 2. When x equal to 2, you have 2 times 2 equal to y, so y equal to 4. So when x equal to 2, y is 4. Okay. I have a 0, I have a positive number. Let's try to have one more point, just make sure I have a good graph. So I'm going to pick another point, another minus 1. So when x equal to minus 1, 2 times minus 1 equal to y. Y is equal to minus 2. So I got minus 1 comma minus 2. So now I have 3 points. So we can go ahead and graph this equation. So right here is the x-axis and here's the y-axis. So we have the x and the y-intercept, which is 0 and 0, which is right here where the origin is. And we have another point, which is 2 and 2, which is right here, 2 and 2. Here's 1, here's 2, here's 1, here's 2. And the next point, this point here is when x is equal to minus 1, y is minus 2. Right there. So we have 3 points lie on the line. I'm sorry, it'd be 4, yeah? I have 4 here, but I wrote that wrong. Oop. But it looks like crooked. So this point here is. So we have 4 is right there. Alright, so now we're going to connect all 3 points together. And connect all 3 points together. The ruler I have here is not working, so I have to use by hand. Let's move on to objective number 3, which we're going to look at a vertical and a horizontal line. And to do that, we're going to graph x equals to 3. The equation x equals 3 to see what happened. Okay. Now this equation here can rewrite at can rewrite as x plus 0 times y equals to 3. Okay, the same equation, but I just rewrite as by put 0 times y, but 0 times y is 0, you see, so an x plus 0 is just x up, so same as up here. So for any value we've chosen, notice that y is always equals to 3 because y times 0 is always 0. So let's put the table like so. So if you choose x to y equal to 1, x equals to 3. If y equal to 0, x equals to 3. If y equal to minus 3, and x also equals to 3. So in other words, no matter what y value is, x is always equal to 3. It's always satisfy the equation. And you notice that this equation here does not really depend on y, because it says that no matter what y is, x always equal to 3. So pretty much what it say. Now let's graph the this line. Now this line here has when the y value here is 0, so this y here has the x-intercept at 3, 0. Right here I have the x-intercept. Okay, so let's graph this guy. So right here is our x-axis and the y-axis. So when x equal to, let's see, have 1, 2, 3, 1, 2, 3. So when x equals to 3, y is 1 is right here. It is the point. When x equal to 3, y is 0. This is the point. And when x equals to 3, y is minus 3. So right here is another point. So then you join all the 3 points together. I have a vertical line at x equals to 3. So this is the graph of the vertical line when x equals to 3. And you notice that the graph, this graph here is a vertical line with the x-intercept right here, which is 3, 0. And note that this graph have no y-intercept because x is never equal to 0. Okay? So in the general, every time you have a vertical line, which is the graph of x equal to c, where c stands for a real number, then you have a vertical line with the x-intercept is c0. So what I mean by this is when you graph this, what I mean, every time you have the equation, okay, every time you have to try to change different color. So every time you have an equation x equal to c, c can be anything. So let's say right here is c, and then your vertical line will be right here, x equal to c. And at this point here, where c is common 0, that is your x-intercept. Okay. Let's draw, this is the vertical line. Let's draw the graph. Next one. Let's graph y equal to 3. Now y equals 3 can rewrite as 0 times x plus y equals to 3. So for any value of x, we're choosing y is always equal to 3. So just no matter what x value here, y is always equal to 3. So let's see. When x equal to 0, y is three. When x equal to 1, I'll do 1. 0 times 1 is 0, then y equal to 3. When x equal to minus 1, you put the minus 1 inside here. Minus 1 times 0 is 0. 0 plus y is equal to 3. So you see this case here, when you have the equation y equal to number, this equation here does not depend on the x value. No matter what x value is, y always equal to 3. Okay, any x value you choose, y always equal to 3. So let's graph this problem. So when x equal to 0, y is 3. So right here. When x equal to 1, y is 3. Right here. When x equal to minus 1, over here, y equals to 3. So this case here, when you join all the points together, you have the horizontal line. This is the y equals to 3. Okay. So anytime you have the equation that's y equal to some number, you have a horizontal line. So this is how we define the horizontal line. The horizontal line, the graph of y equal to c, where c is any number, real number, then we have a horizontal line. And you see that based on this case here, this horizontal line here has no x-intercept, okay, but we do have y-intercept, which is right here is our y-intercept.